Hello and thanks for watching Best Maths Tutors. I'm continuing going through the Edexcel higher tier paper from 2019 and this is paper 3. It's calculator paper, and if you'd like to watch more videos like this, hit the subscribe button at the bottom. This is question 19 and it's a question about boundaries. So we've got to find the upper boundary of this quantity which is given by D. And what we're told is D is actually, we've got an equation for it. So D is equal to U squared over 2A, and we're given the values for U, and we're given the values for A. And we're told that they're actually rounded up, so they're not exact, they're both rounded up. So the U is rounded up to 3 significant figures, and the A is rounded up to 2 significant figures. So we've got to give our answer as well to 6 significant figures. So what we would need to do is consider what would make D be its largest value. So the upper bound means really the largest value of D that we're looking for. So the largest value of D. So for these values of U and A, what is the largest value that D could be? So if we think about a fraction, we've got one number over another. The way the fraction could be the largest, so imagine we want to say D max. So we'll say D max is equal to the top value of the fraction would have to be the maximum it could be. So the top would be the maximum, and the bottom of the fraction actually would have to be the minimum it could be. So if we think about, consider just an ordinary number. So let's imagine we've got 2/3. Let's just imagine we've got that. And if we were to increase the number on the bottom, then the overall value of the fraction would get smaller. So imagine we made the 3 into a 4. 2/4 is actually less than 2/3. So making the bottom number smaller will actually make the fraction bigger, the overall value. Consider comparing that with, if I had 2/2, so I've reduced the size of the number on the bottom, then the overall value has got bigger because 2/2 is equal to 1 whole number, whereas 2/3 is obviously, you consider it like as a slice of pie or something like that. You can see 2/3 is this much of the whole. So 2/3 is less than 2/2. So making the bottom number smaller will make the overall value bigger, and making the top number bigger will make the overall value its biggest as well. So in this case, we need to find D max, or the upper boundary of D. We need U to be the maximum. So we need the value of U, because U's on the top line. We need U to be its maximum value, upper boundary, and we actually need A to be the minimum that it could be. So let's have a look at this. Now we can say, since U's been given as 26.2, we can imagine it's on some sort of scale. We've got 26.2, and the value above that, the next increment above that to 3 significant figures, would actually be 26.3, and the one below, immediately below, would be 26.1. So for us to give a value of 26.2, we're actually in this range, and this range is where this is the halfway point here between 26.2 and 26.3. So it's actually 26.25 is the maximum value that 26.2 could be, and the lower bound here of U, so this is the values of U, are would be 26.15. So what that means is anything above 26.25, or 26.25 and above actually, would be considered to be 26.3. Anything below 26.15 would be considered to be 26.1 if we wrote it to three significant figures. So our 26.2 can mean anything in this range of values. So our U max, the maximum value that U could actually be, would be 26.25. And that's what we're going to be putting into our formula here in a minute. So also we need to look at A as well. So if we look at A, well, A's been given as 4.3 and we need A minimum. Well, the value just above that would be 4.4 and the value below it would be 4.2. So the boundary between the two values there is halfway between. So that would be 4.35 would be the upper value that A could take, and 4.25 would be the lower value that A could take. So what we're going to take then is the lower value that A could have, which would be 4.25. So these are our two values then. So I'll need to use this bit of space down here. So U max is 26.25. A minimum is 4.25. So from these values, we can work out the maximum value of D. So we want the D, and I'll just write upper value. So the upper value of D is going to be given by putting in U as its maximum value there. So 26.25 squared, and over 2 times the A value, which is 4.25, the minimum value that A could be. I'll just get the calculator up now, and so I'm just going to use the fraction button here to work this out. So we want 26.25 all squared on the top and on the bottom line. So I'm just going to use the navigation keys to get onto the bottom line there. We want 2 times 4.25. So if we just do that, then what we should get, if we get it, so it gives it in that form. So these are very standard calculators that you would actually get. So it's very useful to get used to how we can deal with this. So it's given in that form, but that's not the form we want it. So if we press the SD button there, it'll put it in as a decimal. So if we press that, we can see we've got all these figures here. And so we're asked to write it to 6 significant figures. So initially what I'm going to do is I'm going to just write down a few more figures than that. So as soon as I start typing on here, the calculator is going to disappear. So I'm just going to try to memorize this. 81.06617. So 81.06617. Let's just check that's right. 81.6617647. And so we need to write it to 6 significant figures. So what that means is writing it from the first figure that isn't a 0 in here. So obviously that's the 8. So we're counting from there. So 1, 2, 3, 4, 5, 6. So that's our 6th significant figure, the 1. And we're going to cut it off at that point. So I'm just going to change the colour of the pen, hopefully. So here we go. And so I'm going to cut it off there. And what I need to do is I need to look at the next one. So I'm looking at the 7. And that will tell me whether the number in the 6th place there is going to stay as the 1, or is it going to get put up. So because it's a 7 there, so it's 5 or more, we're going to add 1 to the 1. to make it a 2. So I'll just change back colour. There we go. So actually, to 2 significant figures, 6 significant figures, it's going to be 81.066, and now it's 2, and that's 6 significant figures. 6 sig figs. So that's part A of the question done. So part B, I'm just going to make a bit of space now in the video, just so I can explain all this. So what we're told on this next part is that the lower bound for the value of D is given as 78.6003 to 6 significant figures. So that's the lower bound, and we've actually got this one as our upper bound as well. And what we've got to do, by considering the bounds, write down the value of D to a suitable degree of accuracy and give a reason for the answer. So when we're talking about giving it to a reasonable degree of accuracy, what it's saying is, up to what extent can we be sure that our answer is correct? Well, we can see there's quite a big difference between what the lower bound is and what the upper bound is. So it's not sensible for us to write the answer to 6 significant figures, because if we was to give 81.0662, our upper bound, we've no idea whether or not it's correct, because we've got a totally different answer if we look at the lower bound. So what we want to do is give it to a degree of accuracy to which we're sure it's correct, and we do that by seeing to what degree they both agree. So if we look at both of them, so we would say we've got the lower bound, I'll do it the other way around, so I've got the upper one on top, got the upper and the lower. So if we were to write them to 1 significant figure, so one significant figure, then we could see that the upper bound to 1 significant figure is actually 80. So when you're doing a number to 1 significant figure and it's it's bigger than, say in this case, it's to 2. It's in the tens, isn't it? There, so that's what I'm trying to say. So we've got 80 there. So what we do, we need to put a 0 in as a placeholder. So we've only got 1 figure there that's actually not a 0, but it needs to remain in the tens column. So we say the 8 is the first significant figure. And so would the 1 make it go up or not? Well, it would keep it as it was. But so the 8 stays as it is, and we write a 0 in place of that 1 there, the 1 here, because we need to keep the 8 in the tens column. Otherwise, to write it as just 8 would be sort of ridiculous, really, because obviously 8 is nothing like 81. And if we do a similar thing there to the 78 or 78.6003, then I'll just write this here just again so we can see it a bit clearer. So the 7 is our first significant figure, and we need to look at the next place along, the 8, and we need to say, well, the 8 is 5 or more, so that means we're going to add 1 to the 7 there to make it an 8, but so that the 8 remains in the correct column, in the tens column, then we're going to need to write a 0 there. Okay, so they agree to that level of accuracy. If we were to write them to 2 significant figures, then this one, the upper bound, would now be cut off after the 1 there at the decimal point, and we can see the next figure there is a 0, so that it's just going to be 81. And if we'd looked at the lower bound, we'd actually cut it off after the 8 there, but because the 6, so this is our second significant figure, but because the 6 is 5 or more, that's going to add 1 onto the 8, and that's going to be 79. So In fact, we disagree at this point. The upper and lower boundaries disagree. So we don't know which one of these is correct. So for us to write 81 would be, we couldn't be sure that that was correct, and equally we couldn't be sure that 79 was correct. We'd be implying we knew it to more accurately than we really did. So really, all we can say, a suitable value to a suitable degree of accuracy would be 80. So D equals 80 is a suitable degree of accuracy. And what I would say, so I've got to give a reason for my answer in order to get the marks. And what I would say for that is the upper and lower bounds only agree to one significant figure. So upper and lower bounds only agree to one significant figure. And that's it. So I hope that's helpful to you. If it is, please like our video and subscribe to our channel. And for more help, visit our website, which is Best Maths Tutors. Thanks for watching.